Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. This is the third video in the series of videos on the solution of IB Maths AA HL paper 3 questions, and in this video I'm going to solve question number 1 from May 2021 time zone 1 paper 3, and this question carries 27 marks. If you have watched my previous video, you would know that you have 27 to 30 minutes to solve this question. So in this paper you have 55 marks for 60 minutes, which means approximately you have 1 minute for each mark. In this case, then since the question is for 27 marks, you have 27 to 30 minutes to solve this question so that you are in a safe zone. So let's read the first statement given in the question here. This question asks you to explore the behavior and key features of cubic polynomials of the form x cube minus 3cx plus d. You can see that c and d are parameters. By changing the values of c and d, we are going to explore the behavior and key features of this particular type of cubic polynomials. What are the things that we know about cubic polynomials? Let's collect all that we know about cubic polynomials before we proceed further in the question paper. Okay, what do we know about the behavior and key features of cubic polynomials? The word behavior means you are looking into the shapes of the polynomials, and by the word key features you mean x-intercepts, y-intercept, any points of inflection, maximum or minimum, which means any stationary points or non-stationary points altogether form the key features of any cubic polynomial. In this case, the cubic polynomial is of the form x cube minus 3cx plus d, which means c and d are the parameters which are going to be changed. So these are the things that you should have noticed at this point of time. What is behavior of a cubic polynomial? Which means you have to consider the shapes of the cubic polynomials for different c values and for different d values. And also for different c and d values, you are going to talk about x-intercepts, y-intercepts, points of inflection, maximum or minimum, etc. in this particular question. So keep in mind that these are the things that you will be discussing in this particular question. And the function is also of the form x cube minus 3cx plus d, where you are going to change the values of c and d. And you can also notice that there is no x square term in this equation. And another thing that you might have noticed here is d is the y-intercept. Whatever value for d you are inputting here, you will be having that d value as your y-intercept. And since the coefficient of x cube is 1, which is positive, the curve generally looks like this, starting to go upwards, then going down and then going upwards. So d will be the y-intercept and this will be the shape of this curve in general. But there are also other two possibilities. The curve could be like this or like this. So there are different possibilities of this cubic curve, and you can just collect all the information that you could about this particular statement of this question. So first of all, write down everything that comes to your mind about behavior, key features of cubic polynomials, and also analyze what type of equation is given. In this case, you have no x square term and d will be your y-intercept, and there are different forms of the shapes of this curve for x cube minus 3cx plus d. Make a note of all this information in your paper before you start with your questions. This can be on your rough paper as well. It need not be shown on the paper. So just on your extra sheet, write down all that comes to your mind from this first statement. So now that we have collected all that we know, let's continue with the question. The first part of the question is, consider the function f of x is equal to x cube minus 3cx plus 2. In this case, d is equal to 2. And we are going to change the values of c only. In this case, x is all real numbers. Of course, it's a variable, and c is a parameter where c is a real number. So you can change the c values using all real numbers. Since d equal to 2, all these functions for different values of c will have the same y-intercept too. For example, in the graph given below, you should have noticed that 0, 2 is the y-intercept for both the graphs. So in the question itself, you are given the graphs for c equal to -1 and c equal to 0. So the left hand graph gives the equation x cube plus 3x plus 2 because c equal to -1, Because c equal to 0 in the second graph, we have the graph of x cube plus 2. So these are the two equations and two graphs already given in the question. You don't have to graph them anymore. But going further, you are asked to graph for c equal to 1 and c equal to 2. But how are you going to graph them? You are not going to graph them on the same axis. You are going to use two separate axes for this. So c equal to 1 will be graphed on one axis and c equal to 2 will be graphed on another axis. You're going to sketch the graph of y equal to f of x. F of x is x cube minus 3cx plus 2. Remember from the information given before this. And before I proceed, I think you have the copy of this paper in front of you so that you can have an idea about the question as such. And coming to the question, in this graph, you need to show the value of y-intercept and the coordinates of any points with zero gradient. What do you mean by points with zero gradient? These points are maximum, minimum, or points of inflection, which means we are trying to find the coordinates of maximum point, coordinates of minimum point, and coordinates of any stationary points of inflection. So these are the three things we are going to consider along with the y-intercept. Before we proceed further, let's make two separate axes and do not forget to label the axis x and y. Now write down the equation for c equal to 1 and c equal to 2. For c equal to 1, the equation will be x cube minus 3x plus 2. C equal to 2, it will be x cube minus 6x plus 2. So you are going to use your GDC, graph them on your GDC and copy the graph on the paper. Pause the video here, try to sketch the graph of these two functions and then continue with the video. Are you ready now? This is the graph of x cube minus 3x plus 2. And this is the graph of x cube minus 6x plus 2. And of course, the y-intercept is going to be 2. Now let's mark all the important points on the first graph. X-intercept, 1 maximum, 1 minimum, and y-intercept. But you should have noticed that in the question you are not asked to mark x-intercept on the graph. Therefore, let's remove this point. Let's not mark the x-intercepts. We will mark only the stationary points and the y-intercept here, which means you are going to mark local maximum, local minimum, and y-intercept. So we will mark the same 3 points on the next graph as well. Maximum is negative 1.41, 7.66, whereas the minimum is 1.41, negative 3.66, and the y-intercept stays as 2. Remember to give your answers in 3 significant figures in this case. Notice that this question is for 6 marks. Basically, this is not a very difficult question. It's just asking you to sketch the graphs and use your GDC and mark some points on the graph. So this 6 marks should be very easy to obtain, and you should be able to complete this question within 3 minutes so that you can save this time for more difficult questions later in the paper. Let's proceed further to question B. Again, another very simple question for a mark, which is very easy to obtain. Maybe you can spend less than half a minute to answer this question. You are supposed to find the derivative of f of x. F of x is x cube minus 3cx plus 2. Finding the derivative is very easy. 3x square minus 3c is the derivative here. Because it's just a polynomial, it's going to be very easy to do this question. So the first 7 marks are quite easy for you. You can expect the level of difficulty to increase as you move on in this question paper. So question C might be slightly difficult than the first 2 questions. This is for 4 marks, but you might need little more time than 4 minutes here. So if you had saved some time in question A and B, you can use the time for this question. So let's analyze this question. It starts with the word hence. So you have to use the previous results to answer this question. Find the set of values of C such that this graph y equal to f of x has a point of inflection with 0 gradient, which means you are finding stationary point of inflection. In this case, 1 point of inflection should be there. In the second case, you should be having 1 local maximum and 1 local minimum point. In the third case, you are supposed to be having no such points where the gradient is equal to 0, which means there are no stationary points in the function. So in these 3 conditions, what will be the set of values for C? What values of C will give you each of these conditions is the question. So in the previous question, you were asked to find the derivative of the function. So how can you use it here in question C? In all these three cases, the idea is based on the stationary points, which means you are solving the equation of derivative is equal to 0. So in the first case, the equation f dash of x equal to 0 should have one root. In the second case, it should have two real distinct roots, so that one root can give you local maximum, one root can give you local minimum. And in the third case, this equation does not have any real roots, therefore you don't have any points where f dash of x is equal to 0. So these are the three conditions. Looking at these three conditions, you can see that this looks very similar to the discriminant type of questions from the quadratic equations, right? So your f dash of x is a quadratic function, which is 3x square minus 3c. Since this is a quadratic, and since the values of a, b, c of the quadratic are here, substituting these values in your discriminant, the discriminant is equal to 36c. And for the first question, the discriminant should be equal to 0 to have equal roots. Therefore, solving for 36c equal to 0, you get c equal to 0 as your value for c. So first question, the values of c is equal to 0 to have a point of inflection with 0 gradient. Question number 2 has two real distinct roots is when the discriminant is greater than 0. 36c greater than 0 gives you c greater than 0. So for all positive c values, you will have one maximum and one local minimum point. The third question is when there is no real root, which means the discriminant is less than 0. 36c less than 0 gives you c less than 0. So for all negative values of c, there is going to be no stationary points on the graph. So before you go further to question D, take a moment to analyze this question and see where we stand. So we have these four graphs done so far: c equal to -1, c equal to 0, and you have c equal to 1 and c equal to 2 done in question A. Now the values of c for these graphs are c is less than 0 in this graph, c equal to 0 in this graph, and for the next two graphs c is positive, c equal to 1 and c equal to 2 were the values for c. Therefore positive c values gave you graphs like the bottom two graphs, and c less than 0 and c equal to 0 graphs were given already in the question. So what did we conclude from this in the previous question number C? So one stationary point of inflection is when c equal to 0. Therefore, this is the condition for question number 1. For the condition c less than 0, you can see that there is no point where you have horizontal tangent, which means the gradient equal to 0 has no solution, no point where the gradient equal to 0. Therefore, this is a solution for question number 3. Whereas in this case, you have one maximum and one minimum point for positive values of c, which is question number 2. I think it should be question number 2, wrongly written as question number 3 here. So question number 2 gives you one maximum and one minimum point for all positive values of c. So if you have positive c value, the graph should look like either one of these two graphs. For c equal to 0, it should have one stationary point of inflection. Therefore, it should be like your second graph on the top. For c less than 0, there should not be any horizontal tangents. It should keep going up like that. So this is going to be the first graph shown here. Now take a moment again and write down all this information on your rough paper, so you will have an idea about where we are at the moment. This question is asking you to find the y coordinates of local maximum and local minimum point, given that it has one local maximum and one local minimum point. So what does this mean? In the previous question, you know that one local maximum and one local minimum is obtained only when c is positive, right? So when c is positive, you are supposed to find the y coordinates of each of them. So one local maximum and one local minimum point when c is positive. So you have to find the x values first by solving the equation f dash of x is equal to 0. So the x values that you are getting here is plus or minus square root of c. So if you have c as positive value, you have two values, plus square root of c and minus square root of c for x. Substituting these two values in this equation. So first substitute x is equal to square root of c. Pause the video here. Find the values of y minimum and y maximum by substituting x is equal to plus square root of c and x is equal to minus square root of c. If you are ready, you can continue with the video now. So these are the values of y after substituting the values of x as square root of c. So you get minus 2c to the power of 3 by 2 plus 2, and this is local minimum at x is equal to square root of c, and this is the answer for number 2 on the top. For x is equal to minus square root of c, substitute the value in the equation for y. You get the value of y maximum to be 2c to the power of 3 over 2 plus 2 when x is equal to minus square root of c. So these are the two values that you are supposed to be showing. So this is the show that question. So the final answer will not get any marks, but the process is important. So in this case, you need to show how you solve the equation f dash of x is equal to 0, and you are getting two values for x is equal to plus or minus square root of c, and you are going to substitute the values in the equation to find y minimum and y maximum. So this is again a simple question, not a very difficult one. So these 4 marks also can be obtained very easily, irrespective of whether you have solved question C or not. Question E is slightly more difficult than question C. Hence, so again you are using the previous result. Now the question is fixed for positive C values. You know that this graph is going to have one maximum and one minimum points because C is positive, and you have also found the coordinates of y maximum and y minimum so far. So these are the things that you have at hand. Using this information, you are going to find the set of values of C again, but what are the conditions here? The graph should have exactly one x-intercept, exactly 2 x-intercepts, exactly 3 x-intercepts. So now we are going to talk about x-intercepts. Remember that for C positive, you have one maximum and one minimum point. Therefore, the graphs of this cubic function. So what you need to think here is, what are the three types of graphs that you can get when the cubic function has one maximum and one minimum point? These are the three different ways where the cubic function can have one x-axis intercept with one maximum and one minimum. The second case is one maximum, one minimum, but two x-axis intercepts. The third case is one maximum and one minimum point with three axis intercepts. So these are the three cases where you have one x-axis intercept, two x-axis intercept, and three x-axis intercepts. Now what do you see from these graphs? In the first graph, the main thing that are different in these three graphs are that the y minimum changes. The y minimum for the first graph is above the x-axis, which means it's a positive value. Y minimum for the second graph is equal to 0 because it's on the x-axis. And y minimum is below the x-axis for the third case, therefore the value for y minimum will be less than 0. So you can use these three conditions and use what you found in the previous question for y minimum as minus 2c to the power of 3 over 2 plus 2. Solve the three equations. So this is for the first category. Pause the video here and solve for the remaining two and then continue with the video. So for the second category, this will be the C value. C is equal to 1. Then you will have exactly two x-axis intercepts. These are the three sets of values of C that are required for this question. Let's move on to the next question now. The last part of this question. Consider the function g of x is equal to x cubed minus 3cx plus d for x in real numbers, and c and d are also real numbers. Notice that you have both c and d to be changed in this question. You are going to find the conditions on c and d such that the graph has exactly one axis intercept. Explaining your reasoning. So now you have to collect your thoughts again. You have any value for C and any value for D. D is not equal to 2 anymore. Until question E, you maintain the value for D equal to 2. Therefore, you got all the results that you got so far. But in this case, the value of D will be D. C is also considered as a parameter. So, you are going to find the relation between D and C in this case. But what is the condition given? It says exactly one axis intercept. So far, we have got some graphs. Let's collect all the graphs together and see what happens. The first graph, when c was equal to -1, which is c less than 0, the graph was like this. And for c equal to 0, the graph was like this. So we had these two graphs in the beginning of the question, c equal to -1 and c equal to 0. So this can be used now to identify the relationship between c and d for c less than 0 and c equal to 0. In this case, you have d positive because d was equal to 2. Therefore, the y-intercept is above the x-axis. So these two cases are for d equal to 2. Whereas when d is less than 0, the graph would come down. Y-intercept will be below the x-axis. Therefore, it will be a vertical shift of the graph. For any d value, either positive or negative, you can see that c less than 0 will give you one x-axis intercept only. In the same way, for c equal to 0, this graph was when d was positive. The same graph will be shifted down when d is negative because d is the y-intercept, and you can still see that you have only one x-axis intercept in this case as well. Therefore, whether d is positive or negative, for all the values c less than or equal to 0 and for any real value for d, you always have one x-axis intercept for g of x. So the condition for c and d is c should be less than or equal to 0 and d should be any real number. In this, we always have exactly one x-axis intercept. So the next is what happens when c is positive. So when c is positive, you have one x-intercept in certain cases. So you can go back to question E1 where we discussed about x-axis intercepts, right, for c positive. So go back to question E1 and think about all that we did in question E1. So this is the curve with one x-axis intercept for c positive. And this is of course because d was positive, d was equal to 2, the graph was looking like this. When d is negative, the graph would look on the lower side because d has to be on the negative y-axis because d is y-intercept again. But since it has one maximum and one minimum point and one x-axis intercept, this is the only way that the graph can look like. Use some positive values of c and negative values of d and identify what type of graphs you are going to have for positive c value and negative d values. So you can identify the two different types of graphs when c is positive and one graph for d positive and one graph for d negative. Once you identify these two things, you can also identify what happens to y maximum and y minimum in these two cases. In the first case, both y maximum and y minimum are above the x-axis, therefore the coordinates are going to be positive. In the second case, both are going to be below the x-axis, therefore they are both going to be negative. Using the information that you got in question D for y minimum and y maximum expressions, you can have these two here. In the place of 2, you will have d here because d is any d here, therefore d should be maintained as d, it's not 2 anymore. Now use the condition for 1 and condition for 2 and solve the inequalities. You can pause the video here and you can solve for y minimum, y maximum positive in the first case and give an expression for c and d. In the second case, y minimum and y maximum less than 0. Using this expression, find a relationship between c and d again. So you can continue now. So these are the two inequalities you are getting. Combining them together on the number line, you know that you can say that d is greater than positive 2 c to the power of 3 over 2 when d is positive in the first case. The second case is when d is negative. The final inequality you will get is d less than minus 2 c to the power of 3 over 2. So these are the two conditions for c and d when c is positive. The first condition is when d is also positive. The second condition is when d is negative. You have completed the last question of this paper, and the only difficult part of this question was in the last question. And if you have used your graphing calculators efficiently, you could have used different values of c and d and formed an idea about how the graphs look like. So this question carries 6 marks. Therefore, it might take more than 8 to 10 minutes if you have efficiently used your time until question E, you would be able to have at least 10 to 15 minutes to solve question F, in which case you could have done some research with your GDC for different values of C and D and got some idea, and then you could have proceeded to do this calculations. I hope you enjoyed this video. Thanks for watching. Until next time with May 2021 Time Zone 1 Paper 3 Question 2 solution. Bye bye.